Hi, my name is John McMaster here in my Silicon Valley garage.
Hey, and I'm Yusuf. So, John, what do we have this week from you?
Well, as you may be aware, sometimes I work with a lot of chemicals that sometimes can be rather aggressive, like hydrofluoric
And
acid.
I'm Yusuf. So, John,
Do you
what do
know
we have
much
this week
about
from you?
hydrofluoric acid?
Sorry, a small little technical glitch right there, but let's keep going.
Do you know about hydrofluoric acid by chance?
Yeah, it's pretty aggressive, isn't it?
It's very aggressive. And so there are certain operations that I do routinely that I have to handle hydrofluoric acid. And in fact, a lot of times I don't even want to do those for people just because of all the care involved in handling the chemicals. But what if I could automate some of those operations so that I didn't have to handle the hydrofluoric acid as much? Wouldn't that be nice?
That would be nice.
That would be nice. And here's the problem though. Not only does hydrofluoric acid attack glass, it also attacks a lot of other common engineering materials like plastics and metals. But what could you do if you wanted to make something more chemically resistant?
Hmm. What's not very reactive?
Do you have a guess?
Gold.
Gold, yes, and that's what I came up with. And so what my plan was to take some off-the-shelf solenoid valves, primarily used for reverse osmosis water systems in your household, and start gold plating them. So you can see one of the results here. Uh, if you remember a while back, we actually did some electroplating in the before times. Do you remember much about that?
Yeah, so the one thing I did notice was the gold layer wasn't very strong. Like we sparta coated silver rings, and you could basically rub off the gold coating.
Perfect. That is a great point. Do you remember there was a discussion afterwards on Twitter about why the silver coating did not adhere? Do you by chance remember anything about that discussion?
Yes, I believe the bond between the gold and silver atoms wasn't strong enough, and there was some recommendations on uh, plating the silver with another metal and then plating that metal with the gold.
Perfect. Do you by chance know what the industry standard metal is for that?
I don't.
Let's take an industry that maybe you might be familiar with, circuit boards. If you were to order a gold circuit board, say from Osh Park or something like that, what is the gold coating that you get on that board?
I'm not sure what is it
Have you
coated
ever heard of
on.
Have you ever heard of ENIG?
No, I have not.
Oh, okay. Well, a lot of times when you get at least a circuit board, there's a coating called electroless nickel immersion gold or something like that. So the point here is that it's a very common practice that if you want to plate gold onto something, a lot of times you have to put a barrier or what they might call a flash layer on of nickel. Now, in this case, I didn't use electroless, which is a whole other topic, but I did plate nickel on first. So here is a nickel solution I'm using. It's a very large jar. And in fact, this goes on rather quickly. Uh, if you may remember, I also have a gold jar. Look at just like the sheer size difference of the bottles that they give you. Quite a lot, right?
Mm-hmm.
So, anyways, this goes on very quickly, easily. And I did that as a first step to plate this, which we'll go back to in a second. That's not necessarily what you should actually do. And then following that, I was able to put on this gold coating um, from this initially, and I was able to get something that looked. I'm actually going to say closer to this piece here, if you can see this one. And you see this one is roughly gold colored, and you can see maybe this is a better example, which is a little bit more gold colored. But if you compare it to say this one, which may be hard to see in the lighting here, I think that camera angle works. You can hopefully see that this one's a lot more goldy than this one over here.
Yes.
So, can you tell me a little bit? Do you know what it takes to make a high quality, let's say even shiny gold coating on something? What's kind of, or any coating really? What do you need to get a good surface finish?
I mean, I guess thickness of the layer,
Sure.
and you need a lot of electricity for that.
You need a lot of electricity. Okay, so let's talk about a lot of something. So one of the issues that I ran into this solution is, this came in a larger kit, and so I don't want to be too critical on them. But I think there was relatively not too much gold in here, at least relative to the quantities of things that I was trying to plate. What I found was when I tried to run some tests on this, as I was putting current through it, this actually was running out relatively quick, certainly a lot faster than nickel was running out. And so some of the coding issues that I had on parts like this right here turned out just to be this: there just wasn't enough gold in this solution to produce a high quality solution. So do you know what the solution was to that?
What is the solution to the solution?
Buy more gold. So I decided to go with another vendor here. And I should also add, you can buy this by the gallon, and there's some really interesting differences between these two. I don't know how well you can see. Hopefully you can see. Yeah, I guess you can. You notice that these don't look the same, right? What's kind of the difference you see here?
For sure, the color.
Yeah. So do you know anything about gold? You mentioned it's not very reactive, right?
Yes.
So how do you get gold into a liquid solution then like this? Like what are some of the techniques?
I don't know. How would you? It reacts with very few things, right? Like mercury,
Right.
I know it reacts with mercury.
You'll work with mercury, but you'll get an amalgam. You won't get a solution. But
Hmm.
yes, that does help. Do you know what they use in gold mining, for example?
I've only heard of mercury in gold mining. Arsenic, maybe?
Not arsenic, but something also very exciting to humans. Uh,
Cadmium?
Not cadmium.
I could
Cyanide.
go through the whole table
So,
here.
yeah, so cyanide is the traditional chemical that they use for they call gold leaching. And industrially, I believe if you get a lot of like heavy gold platings on things, that's what they'll use, and it gives really great results. Here's a problem: your average person gets a bottle of liquid cyanide solution. First of all, don't drink it. Hopefully that's obvious to most people. But there's actually another hazard that trips people up that they may not be aware of. If I were to take a bottle of cyanide solution and I was to add, say, accidentally some acid, which I'm using at some steps of the process, do you know what would happen to that cyanide solution?
Gas.
That's right. You would release cyanide gas. Do you know what happens when you release cyanide gas?
Well, you'll find out, and that'll be it.
That's right. Yes, it's very hazardous. You should not do that. And so as a result of that, it's actually relatively difficult, I think, or at least chemical. Most suppliers won't want to sell consumers cyanide solutions. So one of the big differences between these is this one is like kind of an eco-friendly, like I'm not sure going to say this one's safe, but this one is least likely to kill you, I guess is the way that I would put this. And this is some relatively complex organic substance, and it has a number of disadvantages. So this one has a shelf life, for example, and I think it's also a lot more expensive to produce. And so I think that's part of the reason why you don't have as much gold in this one as say this one. So does that make sense so far?
Yep. So what's the darker bottle have? Is that the cyanide-based solution?
Kind of. And so that's the interesting thing about this one. So their marketing material says, and I haven't looked into a detail, they say that this is a cyanide complex. And so it's not free cyanide in solution, but I think some sort of maybe an organic molecule or something like that with gold cyanide attached, something like that. I am unclear if you were to add acid to this, if it would produce cyanide gas. I've decided this is not an experiment I would like to run. Uh, so I'm not exactly sure how much safer this is than pure cyanide gold solution, but it sounds like this is some sort of compromise. And one of the other things I gathered too is this does not have the shelf life issue that this one has. And that's one other thing I should also bring up. I've had this for a while, and this claims to have a 3 month shelf life. I think I've had this for maybe 6 to 9 months. So it's also a little bit unfair for me to run some comparisons against this, since it is far past its advertised goodbye date. Um, with all of that in mind, so let's pop the stack a little bit. So one of the things I said to get a good coating, you kind of need, you said a lot of electricity, basically meaning a thick coating. So now we have a thick coating. What are some other things that you might want to do to make a nice coating? So we talked about getting this barrier layer, putting a thick coating on. What else may come to mind?
Hmm. I don't know. I think the addition to the underlying layer is important. You have a nice thick coating.
Let's talk about adhesion. What could impact adhesion?
The bond between the gold and the atoms of the layer below,
Sure. So we attaching the gold to the nickel. What is the nickel attaching to?
the silver, or what is the material your part is made out of?
Yeah. So I believe that these parts are primarily made of steel. So
Okay.
for example, though, I am touching this right now. If I were to try to plate this right now, what would happen?
Oh, oils. You got to clean it.
You got to clean it. Yeah. So that's also one of the really important things. So I did clean this a bit, and I think that helped a bit. But there's one step that I also didn't do, which I think is what you need to do to get really good results. Have you ever heard of electro polishing by chance?
I have, but I'm not familiar with it. I think it just burns off any material on the layer, right on the top layer.
Yeah, kind of like that. The basic idea is the current is strongest at a point. And so if you pass an etching current solution on the surface of a part, it'll tend to etch off the roughest parts first. And if you do that then and do a pass over a part, you can get a very clean, relatively polished surface. And that helps adhesion considerably. Because not only is it a little bit smoother, it's also removed a lot of the surface contamination.
That's interesting because I would have thought a rougher surface would be better for adhesion because it gives you a greater surface area. But you're saying that's not necessarily true.
I think it creates a lot of weak points, so it doesn't actually give you the best finish in the end.
Okay, so for electroplating, probably the smoother surface gives you a nice layer.
Yeah, and also worth mentioning, I never polished this even to start with, so it was never a great surface to start with. I would say that visually it doesn't look too bad. I think even on camera it doesn't look too bad there. But I never really polished it, and I didn't do the electro polishing. So after I polished this in gold, I didn't want to put it directly into my machine to see if the machine would basically blow up. So do you know how you might test this for hydrofluoric acid resistance without actually running it into the real machine?
Dunk it into a vat of hydrofluoric acid.
Exactly. So that's what I did. And in early tests, this thing just went, as the acid was eating the metal. But once I put this coating on here, which is at least halfway decent, I only saw a few small areas where it was getting eaten. But unfortunately, I can't really tolerate small areas. I needed it to be something hermetic. And so at that point, I decided that, it's possible that I could get something like this to work. I would need to go through a more proper etching process. Um, uh, you know, I think the electro polishing is the ideal. It is worth mentioning, I did soak this in hydrochloric acid before, which I was hoping was good enough, but I don't think it was. So instead of that, I went a different route after all of this electroplating work. Instead of using this sort of valve, what else could a valve be made out of that might just resist just about anything?
Glass.
Glass is unfortunately going to be eaten by hydrofluoric acid, but otherwise, that is a good choice.
Hydrofluoric acid. There are some plastics that work.
There are. And in fact, I've been learning a lot about that recently. There's one plastic in particular, though, which is kind of like a bulletproof plastic. It'll resist just about anything.
Oh, I remember this from one of the previous episodes. I'm trying to think.
What might be in your nonstick pan at home?
Teflon.
Teflon. That's right. So Teflon and its derivatives. So I managed to get a few of these surplus Teflon valves. This isn't the same one I'm using in my equipment right now, but it's relatively similar. And so I have one of these installed now, and it seems to be holding up so far. And I think at least for the short term, these are what I'm going to use. The problem with these valves is, do you have an estimate for when I got a quote on a similar valve to this? How much would a Teflon valve of this size cost? Do you have a guess?
Hmm. Uh, $80. $300. $800.
Yeah, so the quote that I got for a valve similar to this was about $500.
Wow.
And so I was able to get a few off of eBay in kind of the $30 to $60 range. And I think that's the path I'm going to go for now, is using these used valves. I'm a little bit afraid though that if I try to turn this into a scalable product, that I'm not going to be able to easily sell something if the valves cost $500 each, and I need a bunch of them in a product. So for now, I'm going to stick with these kind of chemically resistant bulletproof valves. Long term, though, I may return to this and see if I can make it more reliable to scale this up for a more cost effective solution.
Mhm. Like if you were to give these out to somebody to electroplate for you, like what's the cost there? Like is it very expensive?
I did consider that. I think there's going to be a lot of startup costs, NRE. So it probably only makes sense if I ask them to do a bunch of them. And so I think that also is another argument that this doesn't make sense until I'm trying to scale up the product.
Hmm. Okay, very cool, very cool. Couple of questions. So I think we're done with your presentation. So I actually have some practical questions. One is usually when you're electroplating the electrodes that one of the electrodes at least has to be the material you're trying to plate. So do you have gold electrodes in this case, or that's not needed?
So industry recommendation, at least that I've seen so far, I'm not sure if gold electrodes would exchange in the same way that a lot of other solutions would. So for example, I think if you're doing copper plating, you use a copper electrode in a sulfuric acid solution, and that becomes copper sulfate. I don't believe though that gold will dissolve in solution in the same chemical way that you get with other metals. So instead, what they recommend is you either use a lead or a stainless steel electrode. My kit came with stainless steel electrodes, so that's what I've been using.
Okay, very cool. Also, did you happen to figure out why that solution expires? Like, uh,
I don't know exactly, but my just kind of touchy feely answer is that it's a gold solution, which I'm not sure how stable those are to begin with, and it's an organometallic solution, which I think could similarly have stability issues. And my guess is that that's just not a happy molecule, and just over time it's
okay.
great.
So do you actually end up with like gold atoms in just deposited in the solution as sediment or something?
I didn't have it decay that much. To me, it seems like the solution probably still works, at least mostly as intended. I don't think mine was degraded enough to be problematic. But if you wanted to, I still have a little bit. If you just want to hold on to it for a few years, maybe you could find out.
Okay. Very cool. Hey, this was a lot of fun. Great presentation. Thanks for the information.
All right. Well, thank you for tuning in, and I guess we will see you next week.
Bye.
Bye.